Hello, everyone. Good afternoon. Let's get started. Today is our first industry guest lecture given by Josh Morley, so from Moody's. Now it's my pleasure to introduce our speaker today. Josh is a recognized trailblazer and the innovator in the field of Internet of Things, or IoT, in the cloud architecting and the data engineering. Josh is the national practice lead for the Internet of Things and the digital twins at Moody's, and works as a senior technical architect in emerging technology relating to artificial intelligence, data, and cloud, and IoT. Josh has been awarded with numerous personal awards, and as well as being a leader of multiple teams that have received award from a local to global level. Josh gives guest lectures to and speaks at universities, schools, and meetups around Australia, and was the technical co-author of the world's first significant IoT paper focused on Australia, which was published in collaboration with the Australian Computing Society, we call it ACS. The paper's title is Australia's IoT Opportunity, Driving Future Growth. Now I give time to Josh to give us talk about the computer vision today. Okay, thank you, Josh, for coming.
Thank you very much. I'm just going to share my screen.
Yeah. So I gave you the host again. So, set you to co-host in order to do that, right?
No worries.
Let me just... That's a co-host, yeah. So that now you can share the screen.
Awesome, thank you very much. Go over here. And let me know when you can see the screen.
Yeah. Good.
Fantastic. Thank you very much. Good day, everybody, and thank you for dialing in. I'm going to be presenting on seeing through the eyes of artificial intelligence with computer vision. Let's see how I can get this to work. Cool. So innovation is just creativity applied with technology. I like to start a lot of my lectures beginning with this quote. And in artificial intelligence, the quote couldn't be more relevant, as the advances that we've seen over time have resulted in this amazing capability of deriving real value from images and videos. And these advances are thanks to the creative minds who have used their technical acumen to push the boundaries of what was possible. It's funny to think that back in the 60s, they believed they were one generation away from creating synthetic intelligence or strong AI. But here we are 60 years later, and we're actually not really sure if we want to create and reach the point of strong AI. But first, I should introduce myself. Thank you very much, Helen, for the introduction. My name is Josh Morley, and I'm the National Practice Lead for Internet of Things and Digital Twins at Moody's. Day to day, I'm a senior architect with various clients across government, health, mining, utilities, and finance. And I'm sure you've guessed by now that I also give guest lectures at a number of different universities. They're generally in the fields of cloud, data, smart industry, emerging tech, and cybersecurity. Feel free to follow me on Twitter or connect on LinkedIn. I am much more active on LinkedIn, but I've been trying to work on my Twitter recently. So as I said, today I'll be talking about computer vision, and I'm going to start with a brief history of computer vision and then go through kind of the timelines of significant events. Next, I'm going to look at deep learning and how it relates to computer vision. I'm then going to talk through some of the modern computer vision uses, as well as outline a couple of the most sophisticated or the more widely used tools and services that you can use for computer vision. This is going to be both across cloud service providers as well as the open source community. I'm going to give two demos using real computer vision services that are used by enterprise and in industry. The first will do some object recognition and detection. I'll show you the identification of objects in a picture using computer vision, and then the real-time recognition of objects from a webcam feed. The second demo will be focused around facial recognition and facial feature detection, which will get the computer vision to describe the emotions of a person in different photos, as well as some things like feature detection like masks or glasses. Finally, I'll give you a little bit of information about how to differentiate yourself when you're applying for internships or jobs, and leaving some time for questions at the end. And just a warning, I'm going to be bombarding you with a lot of information quite quickly. I don't expect everyone to follow everything the first time. How I've structured this is that you can revisit the different and explore the different components on a deeper level after the session, as well as revisit the lecture after some learnings to fully understand what's mentioned. Some of the stuff I cover, I do at the surface level, but the aim is to expose you to different content pieces that I talk about. So you're given a means to learn about a lot more for the topic than could traditionally be fit in an hour-and-a-half lecture. So with that being said, let's kick into the brief history and timeline of computer vision. Now, I'm sure you've probably done a history of artificial intelligence before, and there's going to be a lot of overlap because the two fields are inherently tied together. But this timeline is a little bit more focused on the computer vision side and the occurrences throughout the history of artificial intelligence. So computer vision really began in the 1960s. Researchers viewed machine perception as a stepping stone to what we now call synthetic intelligence or strong AI. They were effectively attempting to create a match for human intelligence and a general problem-solving capability. Some even claimed that AI could be achieved within a single generation. But in reality, researchers of the time were about as close to strong AI as those binoculars are to computer vision. They might seem, when you immediately glance, that they're related, but then when you look at a deeper level, you can see they're actually a long way from being the same. In 1960, Larry Roberts was the first to disclose the potential use for AI to extract 3D geometrical information from 2D perspective view of blocks. And this really paved the foundation for future researchers, and it kicked off the field of digital image processing. In 1966, Marvin Minsky received a grant to hire a first-year undergraduate student, Gerald Sussman, to spend a summer linking a camera to a computer and getting it to describe what it saw. It's safe to say that they weren't successful at the time, and after those and many other claims about AI proved harder to implement than they originally thought, there was criticism, funding cuts, and a drop in interest for AI. This led to what would later be coined the first AI winter. In the 80s and 90s, there was a comeback, and the community started to come to terms with the complexity of strong AI. So the focus for strong AI dropped and made way for expert systems and machine learning. And this is when we started to see the first deep neural networks appear. The shift towards expert systems was really driven by the ability to develop decision engine-like systems that are based on a series of predicates. Expert systems are comprised of a knowledge base and an inference engine, and the inference engine can be evaluated using either forward or backwards chaining. You can see the example on the right is a backwards chaining inference engine with the goal to make $20. However, after some time, expert systems started to be overtaken in performance by desktop computers. And around 1987, there was another large-scale criticism of AI due to the cost of these specialized systems. Funding was cut for AI again, sentiment dropped again. Roger Schank and Marvin Minsky, who'd experienced the first AI winter, recognized and warned of history repeating. And some of the researchers who'd lived through the first dry spell likened it to a nuclear winter. Then in 1984, the term AI winter was coined and applied to the first and this later upcoming winter. Fortunately, thanks to Moore's law, the Moore's law phenomenon, decades of computing advances meant that in the early 90s and noughties, computers were finally becoming powerful enough to facilitate these AI algorithms. However, researchers were still using terms other than artificial intelligence to avoid the negative stigma that was present at the time until that winter ended. And that brought us to the tens. where deep neural networks really started to shine. A pivotal moment for computer vision was the 2012 Imagenet large-scale visual recognition challenge, where the AlexNet deep neural network got roughly half the error rate of previous years. Computer vision started to become a popular research topic again. And then we got big data. The study of big data exploded in popularity thanks to the huge amount of data being generated. Big data was such a popular research topic that a scrappy uni student from a remote city in Australia got a scholarship to study under a renowned professor in Thailand for a few months to see if they could contribute anything to the field. I ended up doing that by creating the concept of a source store data warehouse and gradual ETL. But it was really the presence of this big data alongside now these more and more powerful computers that and the improved machine learning algorithms that really gave computer vision the massive comeback. And with powerful advances in deep learning since, such as the convolutional and the recurrent neural networks, as well as the availability of the training data, thanks to that big data world, computer vision is finally thriving. And modern computer vision is here. We're not only pushing the boundaries of extracting information from images and videos, but also the creation of digital content through generative neural networks, such as the generative adversarial network. For example, the person on the right doesn't actually exist. That person and that image was generated entirely by a neural network. Speaking of which, I'm now going to go into how you can use deep learning to enable computer vision using the convolutional neural network. I have to give huge credit to Deep Lizard. It's a channel and a company whose video on convolutional neural networks forms the basis of this next part of my presentation. I only go into it at a rudimentary level to provide the appropriate context for the rest of the presentation, as the utilization of modern web services through cloud service providers doesn't actually require you to have a really deep understanding of the underlying mathematics of computer vision and CNNs. But I thought it'd be great to give everyone a background. And if you're interested in understanding it at a deeper level, I greatly encourage you to go and watch the video that they've created on CNNs because it has some incredible information. So as we found out from the AlexNet competition entry, deep neural networks, especially convolutional neural networks, are prime technologies for computer vision. And this is because the convolutional layers are great at identifying patterns, and pattern detection is one of the core operations in computer vision. Using a layered pattern recognition gives you a methodology that's quite similar to the concept of dynamic programming. If you're able to identify and match patterns at a simple level, and then incrementally build up more composite patterns, you're able to effectively reach the point where you're recognizing complex objects through this multi-layered approach. So how does a convolutional neural network differ from a standard deep neural network? Well, surprise, surprise, convolutional networks have convolutional layers and operations. With each convolutional layer, you need to specify a number of filters that the layer has. The filters are the things themselves that are able to detect patterns. A filter might be an edge filter to detect edges, or a texture, could even be a shape filter. Simpler filters will appear in earlier layers, and as the components flow through, you can apply more and more complex filters, and you can reach the point where you have composite objects like a hand or a car or keyboard that are recognized. So what are the convolutional layers actually? Well, like any layer, they receive input, they apply some transformations, and they output the result to the next layer. What differentiates it is that transformation that takes place is a convolution operation. When a convolutional layer receives input, the filter will slide over each X by Y set of pixels and apply a multiplication operation for each pixel in the scope of the source with the corresponding entry in the filter. And it does this until it's covered every block of the input, and the summation and this sliding is called convolving. You can see the example on the right where a single application of the filter against the top left 3x3 set of pixels, they're multiplied with the corresponding entry in the filter and then summed together to give the output value of 51. As the values of the pixels in the input are multiplied by their filter, a consistent approximation result starts to emerge. this representation becomes the output of this layer and the input of the next. Take this example of a 7 by Jeremy Howard. You can see on the top what the input looks like, and on the bottom what the approximated result that is generated by the convolution of all of the pixels looks like. So then jumping back to an example given by Deep Lizard in their video, say we want to use computer vision for optical character recognition with a CNN. We would create filters that match different edges of a character. You can see on the right-hand side, there are 4 different types of filter. Behind the scenes, filters are represented with a matrix and the values for different colors in this case, with -1 being black, 1 being white, and gray being middle, zero being gray in the middle. If we look at the 4 filters being defined, the first is how you represent a top edge in a character. The second is how to represent a left edge. The third is a bottom, and the fourth is a right edge. And then now here we can see the application of those filters in action. You can see the edges are emphasized in the output images, which are below, by white lines. We can observe the difference between the 4 output images and how the filters are used to construct the representations that match with their definition. The white lines in the first image are highlighting all of the top edges. In the second, it shows all of the left. In the third, it shows the bottom, and the fourth, it shows the right. The next layer, you might have filters that look for corners between 2 lines. A layer after that might have a filter to join multiple lines, like the top, middle, and right-hand side. And that will eventually incrementally build up to an understanding of what you're looking at, which is the 7. So at a very high level, that's how convolutional neural networks work. If you're interested and you want more details, 100% go and follow the channel and watch the video, because their description is awesome. So now that we kind of have a foundational understanding of computer vision and how it can be done with a CNN, what are some of the primary uses for computer vision in the modern age? It is quite tough to isolate them to a concise list, as there are many subtypes and subtleties of difference between the different users. But I thought these 4 were adequate for an introduction. Image classification, facial recognition and detection, feature detection, object recognition, and then object tracking. I'll be briefly going over each of these, what they are, and then some of the use cases that they're used for. So image classification is the first one, and this is generally just described as given a single object in an image and a set of discrete labels, classify the object. It's a fairly simple concept, and as you can see on the right-hand side, we have a bunch of single object images as well as some labels defined. And computer vision has been used to classify each of those objects against the label. So you can see the aeroplane, the automobile, bird, etc. And image classification is becoming more and more important in a world of big data and IoT. I'm sure you can imagine all the media that's generated by phones, mobile phones, cameras, IoT devices, and everything else that's out there. Classifying what's in these images and videos can be an enormously laborious task if not for computer vision. You can see on the right, there's an example of classification for retail. It's classified different clothing articles by color and type. And when it comes to image classification, there's kind of 2 ways that you go about it, either supervised or unsupervised training. Unsupervised, which is usually fully automated, doesn't utilize manually tagged training data. It uses specific algorithms such as the k-means or the ISO data. K-means is a method of clustering where you initialize k-clusters randomly or greedily, depending. You then assign each pixel to the closest cluster center. You update the cluster centers by computing the average distance of the pixels in the cluster. And then you repeat those last 2 steps until no pixels change cluster centers. You now have your defined clusters based on the mass and distance. There's an example in the animation on the right. Supervised classification relies on the creation of training or reference samples. This is called the ground truth. And it's going to be used as a baseline to classify unknown data. Image classification solutions will then run comparisons from the ground truth to this unknown data. And often it'll use one of the two approaches of maximum likelihood or minimum distance. And image classification has many, many uses, a lot of which you probably already heard about. There's some fantastic ones in agriculture and environment where they can do things like insect or invasive plant detection. They can identify diseased crops. This is having huge impact on the supply of fruit and veggies. It's also quite frequently used on image-heavy websites such as online shopping, classifying the images into the appropriate search criteria. And on the search criteria, it's used in content-based image retrieval, which is when you want to provide that functionality of selecting images that fit a certain content criteria. And the next one's facial recognition and facial feature detection. This one, a lot of people have been exposed to thanks to the modern mobile phone. But there's a lot more to it than just facial recognition for biometric security. The field actually started off with the goal to detect faces in images, but now it's completely exploded into many different things, such as detecting attributes of the face, such as predicting age, predicting emotions, accessory identification, such as whether somebody's wearing glasses or face masks in the COVID age. You can see an example of facial recognition and feature detection on the right-hand side. That's a picture of when I met Mick Collins, who was the captain of the Australian team at the 2008 World Sudoku Championship. If you're not familiar with his story, it is incredibly funny. It's well worth looking up. Down the bottom of that picture, you can see the facial recognition and detection software has identified me as a male. It's estimated I'm 33 years old, which I thought was a bit harsh, but I was drunk and it was bad lighting. It's identified me to have a smile with 100% confidence. It's identified me as happy with 100% confidence, and it's picked up that I'm wearing glasses. I'll be giving a demo of this facial recognition and feature detection capability a little bit later on. So the process for performing facial recognition can be done in a wide variety of ways, but generally as an overall process, the first thing you want to do is detect where the faces are. You then want to align them to a standard orientation if possible. And then finally, you extract out the features and you'll match against existing faces, which that final step can be done a number of different ways, including using a CNN. Some of the uses for facial detection and recognition include obviously recognition for biometric-based security, as many mobile phones have, detection and recognition of faces in media, such as photos and videos, detecting faces to blur to protect privacy. You'll see examples of that on Google Maps. Analyzing faces for analytics or demographic data, such as people wearing glasses, their masks, people's ages, as well as using social media, such as Google Photos, where it groups all the photos of a particular individual for easy browsing and access. Just left the text box there. One of the next fields of computer vision is object recognition. And this is really about detecting distinct objects within a piece of media and classifying them. You can see on the right, the example shows the differentiation between classification, localization, object detection, and then instance segmentation. Object recognition has applications everywhere. Some of the applications that you might know include security, where there's the identification of intruders from camera feeds, healthcare, where there's some awesome stuff about exploring the ability to use CV to identify things like tumors, growths, viruses, based on different either biometric data or scans. Manufacturing, it can be really useful for automation such as quality assurance, making sure there's no cold shuts or stress fractures in manufactured steel. Additive manufacturing is another huge one that leverages computer vision quite a lot. Mining, you could do something like a core sample identification. Autonomous vehicles is an obvious use case. I'm sure a lot of people have seen the examples from Tesla and places like that, where they've drawn those bounded boxes around objects that the autonomous system is identifying. And there are many, many more. It's one of the rock stars of the CV world. And then you have object tracking, which just takes object recognition to the next level. and it identifies an object and tracks it in motion. This brings additional complexity as the orientation of the object can be changed or the object can become obstructed. You can see on the right-hand side of this demo that I've taken, a person walks behind the sign, and because a significant portion of their body is now covered, they stop being tracked as an object. So there's a lot of work going into this. There are some great solutions out there. I think I just grabbed the wrong video of this demo. So the next thing I'm going to bring up very briefly is just, I thought it'd be great to identify the different forms of speed and latency when it comes to performing computer vision analytics. Generally, the three that we deal with are real-time, near real-time, and kind of historical. I couldn't figure out a good term for the last one. So real-time is generally when you're performing analysis on something that has milliseconds of latency, and it has strict deadlines on that latency. So if you don't meet the deadline, something's going to go wrong, or there's going to be a failure, or the feature won't act as it's supposed to. An example of this might be facial recognition for the purposes of biometric security. If your phone doesn't recognize you quickly and you're sitting there for a few seconds waiting, it provides a pretty poor user experience, and it's more inconvenient than it is just typing the PIN. So that could be considered a failure of that feature. Near real time is when you're performing analysis on something that might have a couple of seconds latency, or it could go up to a few minutes. It's a lot more flexible, as are the deadlines. So deadlines for near real time are much more flexible than they are for real time, and nothing will go wrong if it takes a little bit longer. So an example of this could be just counting the number of people not wearing mandated masks in different areas of a city. That way, you know where you can position some cops to encourage people to do the right thing or hand out fines. And finally, the historical level of latency, which is really, it's just analytics performed on data that's not in transit. It might be stored in a server, it could be loaded from a camera drive, scraped from the web. You're doing historical analysis. And an example of this is what we'll be doing later when we're doing object detection on pictures from the internet that I've pulled, because they've been stored on a website from Imagenet for a while, and I'm running analysis on these historical images. It's not really real time or near real time. Cool. So now that you have hopefully a brief understanding of the timeline, what convolutional neural networks are, as well as some of the different uses and what kind of latency you can perform on, in the next section, I'm going to talk to you about the different computer vision tools and services that are available. It's going to kind of fit into two categories, either the cloud service providers, which I'm using the big three, or the open source community, which I propose some of the more well-known larger ones. So the first of these I'll discuss are the cloud service providers. Because this might be the first time that you're being exposed to some of the capabilities of the service providers and their AI that's available, I'm going to mention all of really the primary AI capabilities that these guys offer, and not just limited to computer vision. The three I'll be talking about are Azure Cognitive Services by Microsoft, Google's Vision AI capability, and Amazon's Recognition. Kicking off with Azure Cognitive Services, they feature 14 different capabilities across the 4 categories of decision, language, speech, and vision. Under the decision category, there's the anomaly detector, which allows you to identify potential problems early on. The content moderator, which is used to detect potentially offensive or unwanted content like adult material. And then the personalizer, which is used to create rich personalized experience for individual users based off their data. The language has the language understanding, which allows you to build natural language processing into your apps, bots, and IoT devices. Q&A Maker allows you to build a conversational question and answer chatbot effectively and add that layer over your data. Text analysis can provide things like sentiment analytics, detection of key phrases, as well as the identification of named entities through text. And the translator is fairly self-explanatory. Under the speech category, there is speech to text, text to speech, speech translation, and then speaker recognition, which is the ability to identify which person is speaking based off just audio, which is pretty cool. And then, of course, we have the vision capability. Here they provide three main offerings with many features underneath them. But broadly, the top one is just your computer vision, all the stuff we talked about before. It analyzes content, images, and videos. Custom vision is where enablement platform for you to deploy your own custom built computer vision capabilities. And then Face API covers all the facial recognition, facial feature detection, all of that stuff. Next up is the Google Cloud AI offerings. So they've got the speech to text, text to speech, their Vision AI, which I'll expand in the next slide. Cloud Translation is their translation offering, which I think most people are familiar with in one form or another. They also offer natural language processing and Dialogflow, which is their really great conversational chatbot and Q&A service. The Vision API features 7 core capabilities. So it's got image classification, which leverages all of their pre-trained models based on Google's enormous data set, as well as their existing labels. But you can create your own custom ones if you like. There's object detection and recognition, content-based image retrieval, optical character recognition, facial detection, but they don't offer facial recognition yet, which is interesting. Explicit content detection, as well as celebrity recognition. In Amazon Recognition, they provide 8 core capabilities: object recognition, custom labeling, content moderation, text detection and OCR, face detection and analytics, face search, and celebrity recognition. Sorry, and PPE detection, which is a really cool one for the real-time identification of people who are not wearing mandated PPE. So next up, we have the open source libraries for computer vision. I've chosen not to include specific computer vision architectures or algorithms such as the YOLO-R or the YOLO, as though the tool, but the tools I mentioned really give you the ability to gain access to a wide number of capabilities and functions. I'll leave in the reference point later on in the lecture some of the stuff that I think you should check out, like the YOLO and the YOLO-R. But these are the ones that kind of the enablement platforms. So OpenCV is the first one. It's an open source library that includes several hundred computer vision algorithms that kind of span across image processing, video analysis, camera calibration, and 3D reconstruction, as well as many other categories. OpenCV began as a project that was originally launched in 1999, and it was originally an Intel research project to advance CPU intensive applications. Where the alpha version of the OpenCV program itself was released to the public in the IEEE Conference on Computer Vision and Pattern Recognition in the year 2000. Some of the modules in OpenCV's image processing are for image filtering, transformation, drawing functions, feature detection, object detection, and then image segmentation. Some of the modules in their video analysis include motion analysis and the object tracking. This is a really cool one that they include under the camera calibration. It's a model for 3D reconstruction and correction of the fisheye camera model. And then we have Tensorflow. So Tensorflow is an open source library created and originally used internally by Google. It was made public under the Apache license 2 in 2015. It's there to assist the development and the training of ML models and includes many libraries across text, image, video, and audio. Some of the libraries that they have available in the marketplace for text include natural language processing, text generation, which is really cool, and retrieval question answering. For image, they have classification, object detection, generation, segmentation, pose detection, which is quite cool, augmentation, and depth estimation. In the video, they also have classification and generation. And then audio, they have speech to text, speech synthesis, event classification, and command detection, which is cool if you're building your own virtual assistants. And then finally, the next framework is SimpleCV. And it's actually a framework to help people build computer vision applications. And their real aim is to make computer vision really easy. and it enables you to perform computer vision through libraries such as the OpenCV without having to deeply understand the math and science behind them. So it really is an enablement platform. Whoops, jumped the gun. So at the first demo, I hope everyone's excited to learn how to do computer vision object recognition and detection, and all get started in under 10 minutes. I've pre-recorded the demos to ensure that nothing goes wrong and I don't waste any time trying to fix stuff. But it might take a moment to set up the sound. So if it does, please bear with me. I did share sound when I clicked in. So the first thing I'm going to show you is how to create an Azure computer vision service and to do object recognition and detection with this service using the built-in API console in the Azure web portal. When you go to do this yourself, you'll need an Azure account. You can follow the link I've got there for a free account, as well as some credits for the first 12 months. If you already have an account and you've used up the credits, so you have no remaining, that's all good because they do have a free tier. The free tier gives you 20 calls per minute, up to 5,000 calls a month. Otherwise, the standard tier gives you 10 calls per second, and it charges less than $1.50 for per 1,000 calls. So it's not like it's a huge amount. So hopefully, can you let me know if I'll click on the video, let me know if you can hear the sound. So we're going to go into the resource group we created Microsoft Azure, and we're going to search for computer vision. It's going to come up with a bunch, but we want the Microsoft service. Click create, choose Australia East as the region, and start typing a name. For the pricing tour, there's two options to choose from. I'm going to go with the standard. Usually you can go with the free. It gives you the 20 free calls per minute, but I'm just going to go for the standard so I'm not capped for this demo purpose. Here's where you can go through for the virtual networks, for your identity, and for your tags. I'm just going to add a tag that I generally use. These are good for billing purposes. And then we're going to go review and create. And when it lets us, we're going to hit create. So we're just going to let this go and create the service. And then when it's done, it'll give us the option to go to the resource. Alright, so now it's been created, we're going to click go to resource. You can see we're taken immediately to the computer vision resource and to the quick start page. There are a few helpful hints here, including instructions on how to get your API key, which you will use to integrate your program with this computer vision service. I'm going to come back to hint 2 in a moment, but hint number 3 has some useful links to quick starters in C#, Python, Java. I'm pretty sure the quick starters are linked to the OCR page. Yep, but you can just navigate to other examples from this OCR link. So you can find them here. I'm also going to link a few in the slides, the better ones that I found. So we're going to go back to the CV service. Firstly, we're going to have a look at the API console. It gives you the ability to test the API without deploying a program. So let's just check that out. Here we're taken to a screen that includes documentation about the API. It's taking us to the read API for OCR and other text-heavy content. We just want to go to the detect object API up here and scroll down and select the Australia East region. It's the region that we deployed the service. Cool. So it's populated a few of the fields for us, but we need to put in our API key and change the URL of the image. So let's go back to the service portal where we're going to grab the API and paste it in. So we'll grab that, take it over and paste it in. I've got a image URL of a sideward facing doggo, and we're going to check out a few others that might be a bit more complex. There's the picture. So paste that in and hit send. It's now going to show us the response. So we can scroll down. What's great about this is it gives you the location for a bounded rectangle of the object that all the objects that is recognized. It's picked up that it is a dog. The confidence isn't super high. That could probably be a little bit better, but because of the sideward facing angle, I'm sure we can test it on some other. So you can see it's got dog, mammal, and animal as other labels. So let's test it out with another picture. This time I have a more complex one with a dog facing with a ball, teddy, there's some stuff going on in the background. So I'm going to go back up and paste this URL in, and then we'll re-execute. We don't need to change the key. Great, it's sent off. You can see now there's more objects in the list. It's got a high confidence that it is a dog because it's a better picture. It's still got the rectangle for each of the objects it's identified. And you can see there's all the other objects. So there's some seating, it's got sports ball. I might just move the picture in so we can see it at the same time. It's interesting that some of the other stuff like the couch is still picked up and identified, and the teddy on the floor I didn't even notice before. The first time I ran it that teddy was there. So these bounded boxes are really cool for the object detection. I'm sure you've seen some demos that have them in them, and I'm going to show you a live real-time object recognition example where it draws those bounded boxes over the image. Cool. So that was a very quick intro on how to create the service and access it via the in-portal API. So we're going to go into the resource group. Did I skip it? Skipped a few. So we're going to go. Awesome. So now that you're in a position where you've created the service that you can access and tested it via the API console, there's a couple of computer vision sample projects that are made available through GitHub. There's a lot around the web, but the two that I'm going to be referencing are both either through the Microsoft or the Azure samples on GitHub. The first is an older version, an older one. It's a WPF that hasn't been updated in about 2 years, but it contains a good GUI that allows you to do multiple API calls from one screen, or to dive into each of the different cognitive service APIs in isolated screens. The second one is a link that it's there because it's a newer one that uses the new SDK. However, for the cognitive services and object detection, it's all command line. So you won't have a nice graphical display that includes your image. You'll just be looking at the text responses to the SDK call. But I thought it'd be great to include there. So in order to get a little bit more out of the demo, I thought I'd show off the GUI version. Just something to note, you might notice the mention of Project Oxford around the place. This was Microsoft's original project surrounding their AI capabilities. So some of the older projects still have reference to them. So this is the first of the projects that I'm going to be demoing. This one's a bit old, but it gives you a really good graphical user interface to represent the different capabilities of the Cognitive Services API. So you'll need to create the computer vision service just like we did. Otherwise, there's a link to do it through that page. We're just going to go back and go to the GitHub repo. Then we're going to download the project, extract it out and open it. You will need Visual Studio. There is a community edition if you don't have one. You can either download it as a zip file and extract it, or you can clone the repo. It's up to you. Here's some of the information talking about how it's outdated and they've followed it up, but the new follow-up doesn't have the graphical interface. Something to be aware of is the linked sub repository. You will need to download this as a separate zip file if you are downloading it that way. So after extracting them out, including the sub repo, we want to open the solution in Visual Studio. It's just in the sample directory. You can open that up because I already have it open. I'm going to close these and then give it a launch. So it comes up with this graphical interface. You'll need to put in your service details. I've already copied mine in, as you can see. By the way, don't bother trying to use those because I have cycled them after this demo. We can now go into the Analyze Image, which is kind of the main page of this sample application. They give you all these different options that you can tick to run against those APIs. So I'm going to copy in the image of the dog. At first, you will see down the bottom, not much has happened because we haven't selected anything. I'm just going to check to see if there's any adult content, which is one of the APIs that they have available. You can see it's come out of it's not adult and there's not racy content. So you're going to change it back to the object detection, which is what we've been looking at, and then hit Analyze. So you can see it's got the bounding box as we saw, as well as all the different labels. It is a little bit disappointing that this demo doesn't draw the bounded box, which is what I was hoping for, but we will address that when we do the real-time demo. So you can have a play around with all of the different APIs here. It's very convenient to have it all on one screen. It'll give you the description, which is it trying to describe what's in the image. It's not too far off. It's mixing up the couch with the carpet. But you know, a dog sitting on a couch is not super far off. They also have the option for you to go to each of these individual screens to call those APIs. So the description, which is what we just saw, will give you a little bit more when you go to the relevant individual screen. So in this case, it gives you a few different options to choose from with different confidence levels. You can generate tags, all those kinds of things that you want when trying to extract out information from an image using computer vision. Awesome. So after that kind of holistic demo, I'm going to dive into another one that captures more of the essence of computer vision. That is to say, it draws those generic video feed boxes around the items with the labels as they appear. Something I noticed when I was creating this demo is that the description engine really seems to be struggling. It just came up as the couch there, but when we dive into this next section, you'll see that there's actually this really weird difference between the objects that are identified correctly through the detection and with the bounded box and what's represented when you get the description back. So that's something I thought was really interesting. So we're going to go ahead and download the code. Once that's completed, we're going to extract it out and open up the solution in Visual Studio. Great. So the one that we're loading is running on an outdated version of .NET. They do give instructions on updating to a newer one, and I'm going to go through that with you. So you can see if we scroll through the output, after running build, it might succeed, but it's going to complain about the mismatch between the versions of .NET runtime that you have on your computer and the one it's using. If you try to execute it, it's going to error, and I'll pull over the log, and you can see that it's trying to find 2.1.1, but it can't. Rather than installing an outdated version of the runtime, what we're going to do is we're going to follow their instructions to port this over. So we're going to create a new project. It's going to be the .NET ASP core with the React runtime. So we're just going to create a new project and solution. Call it whatever you want. Make sure HTTPS is selected by default. And then what we're going to do is copy over the client app, which is the React components, from the old version to our newly created one. This client app directory has all of the React components, including the primary app.javascript. So by copying this over to the new version, the later version of the .NET Core project is going to execute this React components, which includes all the integration with the cognitive services. The next thing you're going to want to do is build the solution. It's going to install all the NPM packages as well as any of the NuGet that it needs. So once that's done, you will have an executable solution. So you hit the run and you should get the window pop up. It'll ask your permissions on the first time to access the camera. Make sure your camera is accessible and plugged in. Then you need to put in the endpoint for the region and your API key. You can also change the frequency. I'm going to leave it at 500 for the moment. So this is what the webcam is currently seeing. If you hit continuously analyze, it's going to continually poll and send those images off. You can see it's classified a toy for my microcontrollers. It's got my watch and it's got my sunglasses. Something that I noticed when I was doing this is the caption and the tags aren't very accurate at all. It seems to be doing the object detection and recognition labeling in the image itself really well. It's quite accurate. You know, it's given the best estimation it can for the toy. But the caption and the tags have been quite off. I'm not sure why that is. Let's have a play around with this. Chuck my hand in here and see what it says. So it doesn't draw a bounded box, but it does get my hand in the caption. Put this can in here. It kind of shifts between container and tin can, depending on how much of a view it gets of the can. I think if it sees the top clearly, then it understands that it is a can. And there you have it. We have real-time object detection utilizing Microsoft Azure Cognitive Services. And we're doing computer vision, less than 15 minutes. So we're going to go ahead and download the code. Once that's I'm on mute. Cool. So for the next demo, we're going to do the facial detection and recognition, still using cognitive services. And for this demo, I'm going to be utilizing that second newer SDK project that I talked about earlier. And while it only had command line samples for the cognitive computer vision, fortunately for us, it has a GUI-based example for the facial capabilities. It's structured very similar in user interface to that WPF that we just showed. And it has screens for a few of the different capabilities that the facial API offers. I'll demonstrate how to, this time I'll demonstrate how to create the resource group and to provision both the face and the cognitive services into the resource group. Because for some of the face API features, you do need to have the cognitive services. I took a few different photos where I'm pulling different faces to try and demonstrate different emotions. I'm also going to demonstrate facial identification, which lets you train a model to label a person. Then if you put a picture with them in it, it will tag that person with the name that you give it. And finally, demonstrate a few examples of facial verification, which is like facial recognition. It's just when given two photos, it'll tell you if it thinks the person is the same person and the degree of confidence that it has. So this is how to create the resource group, which I glossed over earlier. So the first thing we're going to do is go and create a new resource group. This is where we're going to collect all of these services together that we're using for the Face API demo. You just enter a name and choose a region. I'm going Australia East. Add any tags if you need to. And then hit create. Now that we've created the resource group, we can provision the Face API and the Cognitive Services API. So type in Face, click the one that just says Face by Microsoft and hit create. Once again, we're going to make sure that the resource group is correct, add the name, and then choose the pricing tier. I'm going to go standard because I don't want to be limited for this demo, but you can click the free one if you haven't already got one provisioned. Add in any tags, review, and hit create. And it's taking a while, but we'll get there eventually. There we go. Now that the Face API has been created, we can go ahead and create the Cognitive Services API. Some of the facial API features require access to the cognitive services. That's why we need both in this demo. So we're just going to wait for that deployment. Now that that's been done, we're going to hit go to resource. You can see it's taken to the overview page with some information. We're just going to go back and create that cognitive services. So click into the resource group. You can see it's been created down there. We're going to search for cognitive services as we did in the last demo. Click the one by Microsoft, create, select the right resource group, region, chuck in the name and the pricing tier. If you want to use your original Cognitive Services free trial service, you can use that. You'll just use that subscription key and link when you go to input it into the facial program. Filling out the tags again, review and create, and then hit create when it gives you the option. Just got to wait until the service is provisioned, and then we can hit go to resource once it's created. Alrighty, so we've provisioned the two services in the resource group. Let's go back to the resource group and view them. Only one's popped up, hit refresh. Sometimes it can take a while for the newly created ones. There we go. Now that we have both of the services provisioned, we can get on with looking at the sample project. So here we have the GitHub page that I was talking about earlier. It's the SDK one. Fortunately enough, this project does have the facial graphical user interface. It doesn't for the cognitive services. So we're going to download that and extract it out and go to the appropriate solution. I've already built this, so we're going to hit run, and this is the screen that we've got. You can see on the left hand side we have a few of the different capabilities. Enter your subscription key and the URL, click save so you don't have to enter it in the future. The first one we're going to go through is the facial detection. So I took a few different pictures of me pulling different faces. It's going to describe the emotion, it's going to describe my age, you can see the color of my hair, it's looking for glasses. These are all some of the different capabilities that it offers. I'm going to go through some of the different ones. Here is one of me and my father on Father's Day. You can see it's identified both of us uniquely. I don't know why it keeps estimating my age so old. And my dad, there's probably a compliment to him. But you can see generally what it's about. So I'm going to trial a few different faces to see what it gives us in that side and see if it picks up the different emotions that I was trying to pull off in the pictures. So this one's happy. It's pretty straightforward. Yep, it's got happiness. It's all right. Well, it's interesting that it thinks I'm wearing makeup. This one I was trying to go angry. It sets neutral. Then I've got surprised. Yep, that's nice. At least it's picking up with a reasonable degree of consistency. Nah, okay, I was trying to go for musing and pondering in this one. And then sad. Great, seems to know that I'm sad there. So it seems to be picking up and understanding the core emotions. It's interesting that anger, it comes up as more of a neutral. Maybe I just don't have that much of an aggressive face. There's a few different capabilities on the left that we're going to go through. This one demonstrates training a model based off a number of different faces of a person and then identifying that person's face in other pictures through a label. So I've got it, the bunch of photos that I took with the different emotions. I'm actually going to use that to train the model. So I'm just going to load that up if I remember where it is. And then, so you can see it was under a subdirectory called Josh. That's how they get the label. Once that's loaded in and it creates the model of my face, I can choose an image. I'm going to use this one again. And this time when it pops up, it's actually labeled me as Josh. And because we haven't trained the model for my father, he's got an unknown. Moving right along at the speed of light, we're going to jump into facial verification, which is kind of like facial recognition. It's just going to compare two pictures and say the degree of confidence it is that those are the same people. You can't actually use more than one person in a picture. So I'm just going to jump through and try this one. No, it doesn't like that. All right. So I'm just going to load up another picture of just me. Cool, so it's reasonably confident I'm the same person. What about if I try with a few older pictures or pictures where I'm in a costume, I've got facial hair. Let's try this one. This is my rotary profile picture. Oh, probably helps if I hit verify. Cool, so still reasonably confident. Let's try a couple more. Volunteering at Vinnie's. Yep, still the same. What about dressed as Obi-Wan Kenobi? Ah, bugger, there are people in the background. I didn't even notice. And let's try with the exact same picture. There we go, 100% confidence. Well, that's comforting. So there you have it, that's the sample. I would definitely recommend downloading it and playing around with some of the APIs on the left, the verification, identification, as well as the grouping and the similar, and of course the detection and description that we saw initially. By using the free tier, you get the benefit of playing around and learning about some of the intricacies of it without actually having to pay, although if you do go the standard, as I mentioned earlier, it's quite cheap with about less than $2 per 1,000 API calls, and you're not limited to 10 per minute. Great. So the first thing was that one. And because I went through that one pretty quickly, I'm just going to dive in a little bit more detail to this other one that I've got up on the screen, and it focuses a little bit more on the description of facial features and attributes. This is the cognitive face C# sample that's on the left. And this time I'm going to show you a little bit of behind the scenes and how to tailor the program to add more features to your liking, such as other metrics that you get back from the API. Alrighty, so we're going to go to the GitHub and once again download the code while you extract it out. This is generally the user interface you're going to see. It's got the browse button and the description down the bottom. I'm going to tweak it a little bit to make that box bigger and see what else we can add. So I've already extracted it out here. You have to put in your subscription key and endpoint, and then we're going to launch. So it's going to come up with this blank screen. The browse button's on the bottom left. I'm going to load up one of the images that I showed before with the different emotions. Let's start with the happy. It's going to draw the box around the face, and then the description will come down the bottom when you mouse over each face. So you can do it with multiple people. You can see a little bit expanded details for them before with the hair color. Just going to load up another. the angry one. Here you can see before where it just said neutral, it's got the anger and the neutral is just a much lower anger ratio. So we're going to pause that. I'm going to make some tweaks to the code, see what else we can display in the face description, as well as update the box to be a little bit bigger in case anything needs to wrap around or is not being displayed. So we're going to have a look at the facial parameters and see what we can add. I'm just going to scroll down so we can see how that string is constructed and then displayed on the user interface. So you can see the sample code's all fairly documented. Here we can see where that string is constructed using String Builder. It's checking a lower threshold for all the features to make sure that it's not displaying anything that's insignificant confidence. It's building up all the different hair colors, and that's it. So we're just going to go through and find where that text box is displayed on the graphical interface. I'm just going to make it a bit larger so no text is missed when we add additional, and I'm going to make sure that it's set to wrap text around. And just going to change the size of that text box in the display box. I'm going to change it to 90. It's a nice round number. Alrighty, let's just have a look at what other attributes we can add now that we've resized it. So the IntelliSense will pop up with different options. Might add makeup, because it seems to think that I'm always adding makeup. And what else can we add that's not already in there? I think that is pretty much most that we're interested in for the moment, so let's get rid of that. It'll be interesting to see what the makeup returns. So I'm going to load up a picture again. We forgot to add it to the string builder to display in the text box. So we're going to exit out of that, and we've got to go back down to the string builder. I'm going to add it in before some of the larger things, just so it's earlier on in the text box because it'll be quite small. So just going to do a string build append and add the makeup property. I've got a new keyboard, so my touch typing can be a little bit of a liability at the moment. So let's just correct that. Add in some commas and spacing to make sure it's printed nicely. And let's see how it looks. Go in again. And we haven't completely accessed the makeup property as we should. There must be sub-properties that we're not accessing. So as all devs do, rather than reading the documentation, I'm just going to chuck a breakpoint and check out the local variable when we hit that breakpoint. And here we go. Let's go down, check out the face, go into attributes and makeup. So we've got eye and lip makeup. So I'm just going to add those two. It'll be interesting to see what the results are of each of those, because if you remember in the other sample application, it marked me as having makeup in all of those pictures. So I wonder if it's one, the other, combination of both. Obviously it's not neither. So I'm just going to add those in, make sure we get the appropriate property, and let's restart the program. Load up the picture again, and I hit the breakpoint. We'll just continue. There we go. So it thinks I'm wearing eye makeup, but not lip makeup, which I suppose I should be flattered. Still thinks I'm in my 30s, which is not flattering. Get rid of that breakpoint, and let's see. It really thinks I'm wearing eye makeup. So on that angry face staring back at you, we finished the second demo. Alrighty, so how easy was that? In less than 20 minutes, we created a computer vision service, tested it with a few images from the internet, and we tested it with a video feed as well as some selfies. But I think we all know it's not quite that simple. All we did was utilize out-of-the-box capabilities from just one of the possible providers. We didn't do any of the data engineering to create the data flows from disparate networks, and we didn't really have that good results or confidence high enough for a production system. And that's the thing, when you're building for production, there are a number of things that you just don't have to do when you demo. You'd want to make sure that you do have a higher confidence and a higher accuracy. It doesn't really matter how confident you are if it's confident in the wrong thing. And you might need to do specific training for that use case in order to get there. For example, classifying a series of boards on a microcontroller as a toy could be a fatal mistake if the application that you were building was in something like defense. Another way of reaching that is you might just have to build a custom model. When out of the box doesn't really, even with training, doesn't reach the sufficient level of depth, you might have to build a custom one. Of course, you need to build out the data pipelines to get to the data either to an edge device or to the cloud for that analysis. And I went through all those fairly quickly because I want you all to go home and have a play with those systems and services yourself, which leads quite nicely into some of the things that you can do to improve the quality of a computer vision solution. So to ensure you have a sufficient high confidence and accuracy, you might need to do training specific to your use case. So using the example of the microcontroller being identified as a toy, it's not particularly useful if the use case is that we're trying to construct board schematics of IoT devices. So what we can do is train the computer model to understand the different types of boards and differentiate between them. So you could train it to identify communication boards like Wi-Fi, LoRa, Bluetooth, RFID. You could teach it what an ECG board looks like, an alcohol sensor, ultrasonic distance sensor, all of those things. But in the end, the training might not be enough, and you might need to swap either maybe from cognitive services in Azure to the Google Vision API, because it might have a better recognition of electronics, or you might need to develop that custom model yourself. In order to lower latency, you might need to utilize an edge device and push your trained model down to the edge where devices like video cameras can stream the footage to that edge device on a local network speed. That's a great method of dropping latency. Can you imagine the difference in speed between a camera that streams its footage over Wi-Fi through the internet for analysis in the cloud versus where with NBN you might be lucky to get 10 megabits per second compared to streaming over Wi-Fi LAN where you can get actual speeds of around 2 gigabits per second on a great network. But the demos I put together were really just to show you how quick and easy you could get into computer vision. To perfect it or get close, you have to dedicate significant portions of your life. And if that's your passion, it's a really good growth field to get into. Even though I went all through those demos fairly quickly, I do encourage everybody to go have a play and not just look at them through the graphical interfaces, but deconstruct the messages you get back from the API or through the SDK, which leads very well into homework. So I'm just going to mention a few projects that you can work on and experiment with around computer vision. The first one expands on what I demoed today. See if you can create a Windows app for object recognition and detection that places the bounded box over the top using that new SDK. You could try and utilize the projects that have already been made by Microsoft. So an example might be utilizing the GUI of the facial, but ripping out the backend and replacing it with the cognitive services SDK. Or you can try with a different tool, maybe an open source one, or you can create it from scratch. Another cool project is one that I've done in the past, and I highly recommend it. You want to create a project that uses computer vision on a live webcam feed, and it uses text-to-speech to voice the description that you get back describing that video feed. So like it said when we did the description of the picture of the dog with the ball in the hand and stuff like that, it said that the dog is sitting on a couch. That's the description that you want to voice. And this is my way of building on top of that original plan back in the 60s of plugging a camera in to have a computer describe what it saw. This is just kind of adapting it, and the use case that I did it for was for people with vision disabilities as a way of providing vision for them. It was one of the hackathons that I won a commendation from Microsoft It was the hack for good. And we were building a technology along the lines that would end up being incorporated into Skype and now Teams, where you could effectively provide a live closed caption based off a video feed describing what is being seen in that video to the person who might not be able to see. And then the third one, which is a pretty challenging one, see if you can build your own custom CV model. Choose a problem and develop a custom CV model to solve it. But really try to focus on getting real-time latency and a high confidence in accuracy. And these are some of the things that you should definitely check out if you're interested. On the topic of computer vision, you should look into YOLO, which stands for You Only Learn One Representation. It's a state-of-the-art deep learning algorithm for computer vision and especially object detection. You should definitely check out the video on CNNs by Deep Lizard to get a bigger and better understanding of convolutional neural networks. And check out YOLO. It stands for You Only Look Once. It's not to be confused with YOLO. It's an approach to object detection that was the highest performing for some time before YOLO came along. And then I highly recommend checking out OpenAI, particularly some of the recent news surrounding the arbitrary length book summarization with recursive task decomposition. That's really cool. And Project December in particular, there was an example of somebody who used the generative text capabilities of this platform to kind of emotionally talk to their deceased partner. They said that they trained this chatbot, with fantastic generative capabilities to effectively reflect the essence of their partner, and they communicated with them. So that's a really interesting thing to read about. And then AI alignment, the AI alignment problem with both inner and outer alignment is really interesting to read about. They'll give you a lot of cool information, and you can kind of, with each of those, go as deep down the rabbit hole as you want, or you can kind of check it out from a foundational perspective. So that's your homework. And it kind of concludes the technical part of the lecture. The next section, I'll be talking about how you can differentiate yourself from your peers when you're applying for jobs or internships. Although firstly, I'm going to note that these are my observations and thoughts, and they may not be reflected by other people. This is just the way that I think is a fantastic way to go about differentiating yourself. And it's really all around extracurricular, because if you imagine being a hirer and you're reading through all of the resumes for an internship or a graduate position, for the most part, every single applicant will list the same things. And that's the stuff that they're learning at uni. Because everybody follows the same general curriculum, you have the same experience as all your peers. You might have 1 or 2 semesters of a technology that differs from others for like a capstone project or something along those lines. But for the most part, all students come out with the same foundation, and that's for a really good reason. But it means that the burden is on you to differentiate yourself. Because if you're somebody who's done a side project or a number, you've already done an internship, or you've been in things like hackathons or competitions, you'll stand out. So what are some of the things that will make you stand out? Well, I mentioned them, but the big 3 I would recommend are networking, projects, and competitions. Networking is a really big one. The chances are you already have a network. You've got your mates, your fellow students, colleagues at work, the tutors, the lecturers, all these kind of people in your network, but you want to make sure that you stay connected with these people. And you should try and use networking opportunities to make new connections whenever you can with people either in your field or in fields that you're interested in getting into. Keeping in contact with the people that you've met can be a great way for you to hear about a vacancy from their network if it matches your description. I've probably done that a dozen times in the past couple of years. I've heard a mate or a contact is hiring a specific skill set, and then I'll remember somebody that I'd met who was looking for a job and had that skill set, and I'll be able to connect the 2 people. Networks are also fantastic for referrals. A big part of going for any job is having somebody willing to vouch for you and your skills. And as much as it sucks, it kind of, do you think a company would rather, when they're hiring, say, a cybersecurity specialist, would prefer a candidate with a referral from, say, a senior security analyst from Tesla, or somebody with a referral from Baker's Delight? So try to find people who who are happy to be your reference in, and it's relevant to the field that you want to work in. Talking too fast. What are some of the ways that you can build your network? Well, you already have your current connections, but you can meet more people by going to things like industry meet and greet nights, competitions, which I'll go into, through your workplace. Even if you're not working in the field that you want to go pursue a position in, maybe you could reach out to the software or IT or whatever department of the company that you're working in, as well as participating in uni society events. They're incredible, especially if the society relates to your interest or your degree. But it's really important that you keep the connection with these people through LinkedIn. So that's another bit of homework that is compulsory, unlike the others. I want everyone to go and make a LinkedIn if you don't already have one. LinkedIn is an incredibly handy tool to help your career. People really underestimate how valuable it is. People like Bill Gates, Elon Musk, Satya Nadella, they don't need a good LinkedIn because everyone already knows who they are. Until you get to that point, it doesn't matter who you are, you do need one. I'd be genuinely surprised if any of you had heard of me when Helen announced me as a speaker. But when she announced it, if you were curious, you could Google me or something like that. And depending on your Google profile, my LinkedIn would likely be one of the first results that you'll get. And the information that you'll see, which include my current title with Modus, my work history, companies like Google, the honors and awards that I've won, all these things paint a picture of all of your accomplishments and achievements and your skills. And they draw attention. And the next one's really important. Have a professional looking picture. It's the same with many things. A name without a face is really difficult to build a connection with. But if somebody can see your face, you become a real person. I suppose with GANs, it's a little bit different now because you could just generate an arbitrary picture of a person that doesn't exist and use that as your profile, which might be funny for the meme, but genuinely put a picture of you that looks somewhat professional. I say look professional looking and not professional because I know it's not realistic that everyone has professional Photoshop content available to them. My first LinkedIn picture was that one on the bottom right. I'm looking at the camera, I'm in a suit and tie, and I'd done my hair. That was actually taken halfway through my 21st birthday, and I'd had a lot to drink, but you can't tell. It looks professional. The next is fill out every section possible with as much detail as possible. A really good one to fill out is the courses section, because marketers aren't the only ones who can embrace search engine optimization. Unit names are typically very descriptive and keyword heavy. So when you add all of the units that you've taken in your degree or through other certifications to the courses section, you're adding all of those keywords into the searchability of your profile. And also make sure that you add all the projects that you're working on with descriptions that include some of those valuable keywords. And then there's the social aspect of LinkedIn. Follow people who inspire you or they're in positions that you'd like to be in. Follow pages of companies that have content that interests you or that you want to work at. And then just connect or follow people that you meet to maintain that connection. So now onto the side projects. So I've given a couple examples of projects that you can build above. They're a great place to get started. But the projects don't have to be on the side. They could be stuff that you do during your job. They could be uni assignments. You could be doing them by yourself with mates. They could be your capstone. Any project that you work on is worth listing in your LinkedIn. It just adds a little bit more depth and a little bit more searchability to your profile. Also list them on your CV, which I'll get into. But they're really great. You can use projects to enhance your skills as well. If you hear about in-demand skills or you want to move into a specific role in an industry that leverages a lot of a particular skill, you can use side projects or hobby projects to enhance your skill in that field. That way, when you go for a job, you're ticking the boxes that they're looking for. Add the projects to your CV. I kind of generally have two CV documents that I use. I have a long one, which is 5 pages, and a shorter one, which is 2. In my resume, which is the short one, I just list the projects I've worked on and kind of my roles and achievements, all that stuff. The longer one, for all of the projects that I've worked on, it includes kind of the details that are on the screen. It's what I did, the role I was, any desirable outcomes. Like there was an example of a project I worked on where we got global recognition from one of the global CEOs of a FANG company. So listing that on there is, that draws people's attention. So I think it's good to maintain the two different versions. When people ask for your CV, just ask them, do you want a super detailed longer version, obviously built up over time, or would you like the brief one? Competitions and hackathons, they're another fantastic way to dive into a new technology because you can use it as an opportunity to learn new stuff. You can also meet a lot of new people. Winning a hackathon held by a company is actually how I landed my first job. They saw what I could do in action, so they didn't need to put me through any technical interviews because they'd witnessed me building this stuff, which was awesome for me because I always sucked at technical interviews because I was always so nervous. They just gave me 2 behavioral interviews to make sure I wasn't a dick, and then they offered me the job. Luck was a huge factor because I had the exact skills that they needed. But that was because of my previous point. I'd looked at in-demand skills in the fields that I want to work in, and I was working on side projects in those skills to develop them. And on the other side, having a bunch of competition wins on your resume is always a great way to impress companies because your skill is objectively proven. It's not like you're self-writing a project description where you say, I brought success. It's objective. And they're also fantastic for meeting like-minded people. The chances are if you're at a competition or a targeted hackathon, the other people who are there are interested in that problem domain. So they could have, similar interests and stuff like that. So those are my big 3 recommendations to help you get a job or transition into a new role that you want to work in for a cool company, which is a seamless transition into, speaking of cool companies, some of you may not have heard of Modus before, but once you do, you'll start to see them everywhere. In case you hadn't heard of Modus, we have 30,000 people around the world in 20 countries. We recently announced a merger with Azure Technologies, which when completed kind of in the next year or 2, will have over 55,000 people globally, and will be the 2nd largest engineering R&D company in the world. Globally, we deal with everything from the engineering itself to technology solutions and consulting, stuff that I work on, training through the Modus Academy with Anatoly, heading that up for Australia. We've got innovation labs, project management, business consulting. In Australia, we have a real specialty for technology solutions and consulting, and we have 1,200 consultants in the country. These are from project managers, architects, business analysts, developers, all that kind of stuff. We're also specialists in smart industry, and Modus is the Mercedes Formula E, so the electric vehicle engineering partner. That team actually took home the gold this year, which was really exciting for my colleagues in Europe who got to experience that race in person, which would have been insane. And we have a number of AI specialists who have built super cool stuff with a range of tech from deep neural networks, Internet of Things, drones, and graph databases. And of course, we have the Modus Tech Academy, which is the reason that I'm actually speaking to you today. So Anatoly, who's on the call, is the head of Tech Academy for Australia, and he's driving the program, which revolves around highly innovative education and employment advancement. Modus Tech Academy facilitates work integrated learning opportunities, as well as connecting students with real industry projects, which is awesome. There's some contact details for Anatoly on the screen, and he'll also be around for the QA. So if you have any questions for him, feel free to add them. Oh, there's an animation. So these are some of the credits for the presentation. Definitely check out Deep Lizard and Jeremy Howard. I use the template from Slides Carnival and the photos from Unsplash because I'm not a visual person. And thank you for your time and attention. And thank you, Helen, for inviting me. I hope everyone got some value out of the presentation. Once again, feel free to follow me on Twitter or LinkedIn. I expect all of you to do that mandatory homework. And cool, I think that's fairly on time, I think.
Thank you so much, Josh, for this wonderful presentation. and very informative. So yeah, now we have 5 minutes for questions. So probably can take only 1 or 2 questions. So who want to ask? You can just spit out. Anyone?
For example, we have a question while everyone is putting their thoughts together. With all your experience that you have now, if you were to start again, let's say if you were just about to graduate from UTS or from any other universities, what would be some of the areas that you will focus on?
It's a really good question. I suppose so when I was doing my thesis, I obviously did it on big data with Professor Santadam in Thailand. So big data at that time was huge, but there was a kind of big difference between the academia and the industry. And that big difference made me transition into IoT, which, you know, generates a lot of that big data. And if you can imagine, IoT 6 years ago was quite early for a field. And I've kind of always tried to stay on the front of that as it's grown. So the advice wouldn't be very specific so much as it is, if you're able to identify a growth field, I sound like I'm about to pitch Bitcoin or something, or crypto. If you can identify a growth field really early and it interests you, then pour yourself into it, because as it grows, you will grow kind of at the head of that. And as long as you stay 3 steps ahead of the next best guy, then people think you're like this genius god. But it's really just, you don't know what you don't know kind of stuff. So a lot of the stuff that we mentioned today is a really good seam between academia and industry, in that the researchers are really pushing the advances for artificial intelligence, especially for this new stuff. Generative is really cool. I'm working on a project that I can't talk much about with generative neural networks and creating art, something in that field. I can't talk much about, but people will find out by the end of the year. But yeah, if the main thing is really what your motivations are. Like I love IoT. I love the health application of IoT. People might have noticed that I've built my own like Holter device, so continuous ECG monitoring for heart fluctuations, stuff like that. I do a lot of emergency ER or ED stuff around real-time biometric patients, stuff like patient monitoring. So find something that you're really interested in. The fact that you're taking courses like this and you're already looking into, you know, computer vision, AI, and neural networks, that kind of stuff means you're definitely in the right field. So yeah, without taking much more time and being a super generic answer, that's it.
Thank you, George.
Great. Yeah. So Josh, can I just ask you, would be able to share your slides with us? Or?
Yeah.
Okay,
so I'll send them all through.
Okay, great. So that's very helpful.
Yeah, definitely.
Anyone have a burning question? So I have 2 minutes.
I think we have one question in the chat. It's from Aiden. What sort of frameworks do the AI specialists within Modis work with?
That's a really good question. I'm not across all of them. I know that we typically build our own custom ones. We're cloud agnostic. We do primarily use the cloud service providers, just because it's much easier to integrate with a wider business and enterprise system landscape. We've built one of the really good examples. I'm not sure how much I can say, so I'll be very careful. Is we built a custom model around graphing the relationships between people for kind of investigative reasons through justice agencies of the government. So if you can imagine plotting out using graph technologies and then analyzing and building, constructing these networks of relationships between different people, different assets, locations, all that kind of stuff on a mass scale. That's one of the cooler ones, but I wasn't on that project. I'm not sure how much I'm allowed to say.
Yeah, I got a question as well. So what's the difference between having some AI in like a production environment versus a development environment, and how different is it?
Yeah, it's a really good one. I suppose if you kind of define development environment to cover things like proof of concepts, demos, like we did, it's a lot looser. You create kind of that development environment in a way that you can best focus your time on making sure that AI is as accurate or as efficient, or it's as close to what you want it to do as possible. So to prove out a concept, you might say, we're going to use computer vision to analyze medical imagery data source so that we can identify COVID in people's lungs. In that case, when you're proving the concept, you're just going to put all of those files into an easily accessible place. You're going to make an ideal environment so that you can focus your time on building and training that model. In terms of a development and production environment, with development as a kind of an initial staging ground that you then promote the content that you're writing into production, it'll very much be realistic. I'm not sure how much of a background people on the call have in kind of CI/CD or DevOps, but you often have multi-stage environments where you might have dev, test, pre-prod, and prod. The dev is where you hack around stuff, you build the functionality out, you then promote it into testing for verification, quality assurance. Pre-prod is now the combination of those kind of non-production systems, but it's in an environment that's supposed to pretty accurately reflect a production environment. And that's where hopefully you'll catch production bugs before you get to production, so that people using the system aren't impacted by that. So it's kind of the two approaches with the dev as a means of promotion to prod, or dev in the kind of R&D space.
Thank you so much for this advice. So without further questions, I'll probably call for close of the session. So some people need to go to the other class. So thank you again, Josh and Anatoly, for your